am never, and I mean never, going hiking with you again. We've been lost for over 6 hours, and it's an absolute miracle that we ever found our Jeep.
Look, I'm sorry. This will never happen again. I'm getting one of those satellite GPS deals.
Hi, I'm Tim Ezel. Welcome to the Outdoorsman's Guide to GPS. You know, I've added a new item to my hunting equipment this year. It's called the GPS Navigator. Never again will I have to worry about getting lost on my way back to the truck. I can go further into the woods than ever before in search of trophy deer, knowing that if I find a good-looking spot, I can return to the exact location at any time, in any weather. And more importantly, I don't have to be a computer genius to use it.
The Global Positioning System is a navigation system developed by the United States Department of Defense primarily for military purposes. The system consists of a constellation of 24 satellites that circle the Earth twice daily. The satellites, located approximately 11,000 miles above the Earth's surface, transmit radio signals that can be used by GPS receivers to compute position, course, and speed. The sophisticated navigation system is available worldwide 24 hours a day and provides reliable information during any weather condition.
Look what I got.
What is it?
It's a GPS handheld unit. It's extremely small and lightweight. It says it will operate up to several hours on 4 batteries.
How much did it cost?
Just a couple $100. Not bad, huh?
Not if you promise we'll never get lost again.
I promise.
There are numerous makes and models of GPS receivers available to the public, ranging from small, economical, portable handheld GPS receivers to highly sophisticated fixed-mounted equipment that is capable of displaying navigation information over large color digitized charts or maps. Fortunately for many, even the most inexpensive models are capable of providing extremely reliable and accurate navigation information that can make your adventures safer, more productive, and enjoyable.
As a hunter, I prefer to use a portable handheld unit, but if you're a fisherman, you may want to use a fixed mounted receiver.
This thing, it isn't working. It isn't telling me anything.
Come out from under the tree. Those leaves and limbs are probably blocking the satellites.
There we go. It's showing me where they are.
The very first time you use a GPS receiver, it may need to be initialized or told approximately where it is and what time it is. Some units require you to do this manually by entering the approximate location, date, and time, but most units will do it for you automatically, although the self-initialization process may take some time. Usually, however, only a few minutes are required.
Now, most GPS units can find their exact location in the world when they're brand new, right out of the box. However, this process can take as long as 15 minutes. This is because it must obtain what is called an almanac from a satellite to determine its approximate location in the world.
In order for a GPS antenna to receive signals from a satellite, it must have an unobstructed view of the satellite. Although GPS signals will pass through such things as glass and canvas, large obstructions such as buildings can block reception of signals if located within a direct line of sight between the satellite and receiver.
Now, when you're getting a position fixed with your GPS receiver, you want to make sure that the satellite signal is not being blocked. So you want to steer clear of any trees or other obstructions that might block the satellite signal. This ought to work.
Position simply means your exact location. Coordinates are a pair of numbers used to define a particular position. GPS receivers express your horizontal position as coordinates of latitude and longitude. Now, just in case you're not familiar with the terms, latitude is the number of degrees you are north or south of the equator. Longitude is the number of degrees you are east or west of an imaginary line that passes through Greenwich, England. Longitude lines all pass through both the north and south poles. Longitude and latitude coordinates are expressed in either degrees, minutes, and seconds, or degrees, minutes, and fractions of minutes. Latitude is expressed as either north or south latitude, and longitude is designated as east or west hemisphere. Your position can also be expressed in terms of altitude or distance above sea level. 3 satellites are required to determine a horizontal or 2-dimensional position, and 4 are required to determine both horizontal and altitude or a three-dimensional position.
Another neat thing about the GPS receiver is that it provides you with what I like to call an exact address. For instance, this exact location where I'm sitting right now is at 30 degrees, 15 minutes latitude, 85 degrees, 20 minutes longitude, and is 250 feet above sea level. No other place in the world exactly matches my position coordinates.
The military grid reference system is the coordinate system used by most modern land maps. A grid zone is used along with a 100,000 meter square designator and an easting and northing coordinate. Universal Transverse Mercator, or UTM, is a coordinate system used for land navigation and mapping. It is a metric grid type system that uses a grid zone and an easting and northing coordinate.
You got everything?
Yeah, I think so.
You got the water bottle?
Put it in the backpack.
Alrighty. Hold up just a sec.
Oh, what are we waiting on? Let's go.
I'm making certain I know where the Jeep is this time. I'm getting what you call a position fix.
One thing you must make sure of is that you're getting an accurate position fix. This satellite status page shows me exactly how many satellites we're receiving, the strength of the signal, and the quality of the position fix.
Once a receiver has been initialized, the process of determining your position becomes much faster. Some GPS receivers can acquire your position within a few seconds from power-up. If you should move a receiver several hundred miles with the power turned off, it may need to be reinitialized. The same thing is true if for some reason the receiver should lose its internal memory, which is usually maintained by a built-in battery. Normally, however, unless you deliberately erase a receiver's internal memory, it will be safely maintained for years. The Global Positioning System provides position and velocity readings that are accurate enough for most civilian uses. At this time, it is the policy of the U.S. government to deliberately slightly degrade GPS signals provided for civilian or non-military use. In other words, the signals are made less accurate and the degree of accuracy can be changed at will by the U.S. government. Position and velocity accuracy slightly changes with time as the satellites move around or change their position in the sky. The geometry or position of the satellites being used in relationship to each other also affects the accuracy at any given time. Typically, the reading from a GPS receiver will have an error in position of less than 50 meters or 164 feet. A typical error in speed is usually 0.5 of a knot or less. The average accuracy of the system may be better. If the position of the satellites in the sky are not favorable, or if the lines of sight between a GPS antenna and the satellites are being obstructed by buildings, trees, bridges, or other structures, then the errors can be larger. Higher accuracy is made possible in certain areas by a system called differential GPS. By utilizing a separate radio receiver, GPS signals can be corrected and sent to a receiver that is differential ready and properly set up. Some GPS navigators have built-in differential receivers. A typical error of a differential corrected GPS position reading is 3 meters, or about 9 feet. Generally speaking, differential corrected GPS signals negate the effect of selective availability or the error deliberately induced by the government for civilian use. It is possible in the near future that selective availability will be done away with.
Hey, look at this. It's hard to determine exactly where we are, and even gives us our altitude.
Pretty neat. So what is our altitude?
264 feet, it says. I guess that's above sea level.
How many times have you gotten out in the great outdoors and lost all track of time? Well, you don't have to worry about that anymore if you have the GPS receiver. You see, it operates off atomic clocks located in the satellites.
I wonder what time it is.
21 minutes after 1.
Hey, you're not even wearing a watch. How do you know what time it is?
This thing knows exactly what time it is, and in fact, that's how it works.
While the receiver displays my position, simply knowing the coordinates doesn't necessarily do me any good. But with a map, I can determine my approximate location and where other things are in relationship to me. For example, there's the lake that's right behind me, and about a quarter of a mile over that hill over there is a swamp. But there's a big buck waiting for me over there. some people might not want to take the time to learn how to read a map or chart, but let me tell you, it can be useful information. I'm finding all kinds of things here. I'm going there tomorrow.
All maps and charts are based on certain models or datums. The particular datum used can be found in the legend. The setup functions of most GPS navigators allow the user to enter the datum of a particular map or chart used. You should always check to see the particular chart or map datum matches that which the GPS navigator is using.
Another useful feature of the GPS is that it can tell you the exact speed and direction in which you're traveling. I better hurry or I'm not going to make it back to the truck by dark. And believe me, I've got a long way to go.
One big advantage of GPS over less modern navigation systems is the speed displays are much more accurate and are usually updated as often as every second. Course is the angle from north to the direction you are actually traveling. It is sometimes referred to as COG, or course over ground. It may also be referred to as track.
Okay, now I'm confused. It's showing me all these numbers, but it's not telling me where I am.
No, but the map will. See your numbers. We're right here.
Great, so that means we still have to go all the way around the pond to get where we're going.
Exactly.
Of all the things the GPS navigator can do, the most important feature to me is being able to go from anywhere in the world to any other particular point of interest.
Navigation is the process of getting from one point to another. It involves determining your position, selecting or plotting a course over which you want to travel, and following along that course. A line representing the shortest distance between a point you are traveling from to a waypoint you are traveling to is sometimes called a course line or intended course.
So, where are we headed today?
I'd like to take a look at that area that has all the sinkholes.
Have you figured out how to get there yet?
Pick the coordinates up right off the map. Since we've got to go around the lake, I formed a route.
Waypoints can be entered into a GPS navigator without your having to be there. You can pick the coordinates of any position from a map or chart and enter them into your navigator manually. You can even name the waypoint so that you can easily recall it without having to remember a particular number that identifies it.
Once you've entered a waypoint into your GPS navigator, all kinds of navigational information becomes available. For instance, I've entered the coordinates of a waypoint called Oak Grove, where I want to hunt today. So I just press Go To, Oak Grove appears, and I press Enter. And here we go.
When a GPS navigator provides navigation data from your position to another point of interest or waypoint, it provides the shortest and most direct path or route to the point, irrespective of any obstructions that may be in the way. You should always exercise caution and use common sense and good judgment to make certain to every extent possible that the route is clear of any potential hazards or obstructions prior to proceeding. During navigation, you should continue to visually observe the route for any unforeseen hazards that may occur or appear. Range is the distance to a particular waypoint. Bearing represents the angle expressed in degrees between the direction to north and another point. Bearings can be expressed as true or magnetic bearings. True north is the direction toward the North Pole. Maps and charts are usually based on true north. Magnetic north is the direction toward the magnetic North Pole. It is not the same as true north. The needle of a magnetic compass points towards magnetic north. Magnetic variation is the angular difference between true north and magnetic north. If the variation is west, it's called a plus variation. If it's to the east, it is referred to as a minus variation. Cross-track error is the distance that you are either left or right of an intended course line. Speed over ground, or SOG, is your speed along the actual path of travel over the ground. Speed towards destination is the speed at which you are approaching your intended destination. If you are traveling off course, then your STD will be less than your SOG. Speed towards destination is sometimes referred to as velocity made good, or VMG. Time to go is simply the amount of time it will take you to reach a destination if you continue at the same speed and course. It is often designated as TTG, but can also be referred to as estimated time en route, or ETE. Estimated time of arrival, or ETA, is the time of day you will reach your destination if you continue to travel at the same speed and course. GPS time is determined by atomic clocks located in the satellites. In fact, your position is determined using time measurements by a mathematical process known as triangularization. If you take the shortest, most direct path to a particular waypoint, you would travel directly along the course line to the waypoint. Course deviation indicator allows you to see your position in relationship to the desired course line as you travel to a waypoint. Your position could be on course, or either left or right of the course line. Usually, the scale of a course deviation indicator, or CDI, is adjustable in order that you can set the scale or range to best suit your particular needs. There is a very common and simple steering display used by many GPS manufacturers called a compass steering display, or sometimes an arrow steering display. An arrow, usually inside a compass rose, points toward your waypoint. If the arrow points to the right, you should turn to the right, or if it points to the left, turn to the left, or if it points straight up, you're right on course.
Whoa! Now, one thing a map doesn't show you is thick underbrush like this or anything else that might be blocking your path. So I'll have to deviate from my original course, so I'll just mark this particular place, store it in memory, so I can keep a record of how I go.
Now what are we going to do? It looks like the GPS let us down. I suppose we have to swim this lake?
Oh no. No, I'll tell you what. I'm going to save this spot as a waypoint. That way when we come back, we'll know exactly where we made the turn. How about it?
Let's go. This way.
Now today I've decided to leave the truck here on the main road and try this ridge over here. Problem is I have to go around this lake and miss this swampy area over here. So I've picked 3 coordinates off this map, entered the waypoints into the GPS unit, and it formed a route. This should take me to the ridge without any problem.
A route is a series of waypoints joined together by legs that lead to a particular destination. Routes can be followed in either a forward or reverse direction. Routes are useful when it is impractical or otherwise not appropriate to travel directly to an intended final destination. A route is formed from waypoints that you have either previously stored or from waypoints you create while forming the route. The bearing and range of each leg of the route is usually displayed as the route is being formed. Methods or the particular button-pushing sequences to forming routes manually varies depending upon the particular make and model of GPS equipment being used, but the principles remain common. When the route is complete, it is possible to review the bearing and range of the legs individually, as well as the total distance of the route prior to storing or saving the route in memory. Following a route, either in a forward or reverse direction, is just like going to any waypoint. You just do it one waypoint at a time. The same navigation displays used for traveling to a waypoint are used in the same manner to navigate the route.
Look at this. We're right back where we first started. Now all we need to do is head back east to get back to camp.
Well, I made it to the Oak Grove, and this should be a great spot. I can't wait for deer season to open. Now to get back to my truck, I'm going to form a route from the stored positions of where I changed directions.
We need to turn back to the left over here. We're getting way off course.
Sure you know what you're talking about?
Well, you said we were supposed to be following the dotted line, and we're way over here.
All right.
Track plotters are yet another very useful navigation screen that many units feature. They give you a bird's eye view of your present position and continually plot your track or course as you travel. You can easily change the scale of a track plotter by zooming in or out. Zooming in lets you view a smaller area of the screen in more detail. Zooming out lets you view a larger area around your present position. Panning is a feature which allows you to pan or view other areas of interest which are not currently shown on the display. Following a previous track on a chart plotter is easy. You simply trace the previous track displayed. If you've entered a destination waypoint or a route, you can display your intended course line and destination waypoint on the plotter screen. As you travel, you can see the actual course or track taken in relationship to your intended course line. It makes it easy to stay on course and to see your position in relationship to the destination as you navigate. Some GPS navigators make it quick and easy to form a route. It's sometimes called a breadcrumb route, by utilizing a previous track or course traveled. This feature automatically establishes waypoints and legs of the route with a few simple keystrokes.
A good way to follow your route, or just keep track of where you're going for that matter, is with a plotter. The GPS track plotter actually draws your course right on the screen.
Chart plotters can display digitized charts or maps on which your position, track, intended course, and destination, or even a complete route can be shown. Numerous features can be selected for your particular needs and use depending upon the type of cartography the chart plotter uses. You can customize the displays of chart plotters by selecting the particular information you want to display. Most types of cartography include much more detailed information than you would want to display at any one time. You can unclutter the display by eliminating information not useful for your purposes. A fast, easy way to establish waypoints, even form an entire route, is to use the cursor to pinpoint destinations on digitized charts or maps. Once the cursor is located where you want it, waypoints can be formed with the push of a button. Following a route on a chart plotter allows you the benefit of being able to see your intended and actual course taken in relationship to other things on the digitized chart or map.
In addition to hunting, I also enjoy fishing, and for that, I'm getting a GPS navigator that uses small digitized map and chart cartridges. You can get one of these cartridges for just about anything available on paper.
Some GPS navigators feature a data display that provides the rising and setting times for the sun on any given date at any location. Moon phase displays are yet another feature on some GPS equipment. The rising and setting time of the moon, as well as the phase of the moon, are provided for any given date and particular location you choose. A simulator mode allows you to use a GPS navigator without it receiving signals from satellites by simulating real situations. It's a very useful tool for learning to operate GPS navigators, as well as an aid in planning trips. The data stored in memory on some GPS receivers can be downloaded to a personal computer. This feature usually requires a separate PC kit, including a cable and software. We're certain that with the rapid advances in GPS technology, that new and useful features will continually be developed.
Well, it's the end of the day, and obviously I didn't get a deer, but thanks to the GPS, I found every spot I was looking for, and maybe more importantly, I made it back to the truck. You know, it's important to be able to operate the GPS with confidence. In addition to studying the owner's manual, I viewed instructional videos by Bennett Marine Video. Watching these tapes made the learning process even quicker and easier. If you don't already own a GPS, take my advice and get one. You'll never have to worry about getting lost or finding your way anywhere ever again. I'm Timmy Zell, hoping you enjoy the great outdoors as much as I do.
Now, you do not necessarily have to be at a particular place or location to save that position as a landmark. You can manually input the position coordinates of a particular location in memory without having to be there. These position coordinates could come from a friend, say for one of his hot fishing spots, or you can get them from a map or chart. For example, if we wanted to enter the coordinates of the point of this island, you would first need to determine the coordinates of that position. Using a set of dividers, or even a ruler for that matter, we can measure the vertical distance between the point of the island to the edge of the chart and transfer that distance to the scale at the side of the chart in order to determine that the latitude is 31 degrees, 55.1 minutes north. Now, if we use the same procedure and measure the distance from the point of the island to the side of the chart, and transfer that distance to the top or bottom of the chart, we can determine that the longitude is 81 degrees and 4.7 minutes west. Now we're ready to enter the coordinates of the point of the island into memory and save them as a landmark. Now you may be using a large or intermediate scale land topographical chart or map that displays position coordinates as UTM, or Universal Transverse Mercator coordinates. UTM coordinates is a metric grid system that is used on most maps of this type. So you can determine the position of any particular place shown on a map or chart using UTM coordinates in the same manner that we just did using latitude and longitude coordinates. First, measure the vertical distance from any place on the map, say the particular location to the top, and transfer that distance to the edge of the map and determine the coordinates. Then you would measure the horizontal distance to the edge of the chart using dividers or a ruler, and transfer that distance to the top of the map and determine that UTM coordinate. Similar to the method we use to determine the position coordinates of a location on a map or chart, you can always determine your present position For example, if your position fix was 30 degrees, 13.8 minutes north, and 85 degrees, 54.03 minutes west, you could determine your position on a map or chart as follows. From the scale at the side of the map or chart, you would locate the latitude and draw a horizontal straight line across the map or chart. Next, locate your longitude along the scale at the top of the map or chart, and then extend a vertical line up or down that crosses the horizontal line. This would be your approximate location on the map or chart. Another more accurate way would be to use a set of dividers or ruler to measure the horizontal and vertical distances from the scales on the top and sides of the map or chart as we did previously. Always keep in mind anytime you go to a destination landmark that the unit provides navigational information in the most direct or shortest distance from your position when executing the go-to to the destination landmark. You should always check to make certain there are no unforeseen hazards or obstructions between the point that you perform the go-to and the destination landmark. For example, if you save the location of a boat dock on a lake and then travel around a point into a creek some distance away, and then desire to return back to the dock from there, performing a go-to will provide navigational information that takes you across dry land. Or, for example, suppose you travel deep into the woods and put up a tree stand. Mark that location as a landmark and later attempt to return to the tree stand from your vehicle. Well, you may just find that the shortest, most direct route takes you across a large lake or some other obstructions that would block your course of travel. You can always form a route. A route is a series of landmarks that, when connected together, lead to a final destination landmark. For example, you could leave the dock at the lake and travel in a fairly straight line to the point at the mouth of the creek, and then save that location in memory as a landmark. Next, you might travel up the creek in a fairly straight line some distance and start fishing. You could simply first go to the saved landmark at the mouth of the creek. Then you could go to the location of the dock using the Go To feature. But you could also form a simple two-leg route.